With these limiting reagent problems, we'd like to get to the point where we could save ourselves some math, because what you really don't want to do with these equations is have to solve 3 or 4 different steps for each reactant. You'd like to have a quicker way of identifying so you can do some less math and just speed up the process. So let's do that. And this works for whether you're going to do a rice table or you're just going to do the math method. So that way you can make your life easier. So what you want to do is have a way of identifying the limiting reactant. So what you want to be able to do is take this ratio, so 2 graham crackers, 1 marshmallow, 1 piece of chocolate, 2, 1, 1. And what you're really interested in are pieces, your moles. So take your starting materials, 31 grams of graham cracker, 11 grams of marshmallow, and 17.25 grams of chocolate. Just get your moles. So if you divide by your molecular mass, you're going to get your moles. You say, okay, I've got 4 moles of graham cracker, I've got 2 moles of marshmallow, and I've got 1.5 moles of chocolate. Wait a minute, it's a 2-1-1 reaction. So if everything were equal, this would need to be 4-2-2. Oh, I'm going to run out of chocolate because it's not at that 4-2-2 ratio. I'm going to run out of that first. Okay, so that's my limiting reactant. It's below that 4-2-2 threshold. Oh, well, what's that going to mean for my reaction? Let's think about that. So I've got 1.5 moles of chocolate, 1.5 moles of marshmallow disappear, 1.5 moles of s'mores appears, and 3 moles of graham crackers, disappears. You'd think if at home with practice I would know that. Disappears. Do my best Homer Simpson. Duh! Okay, it's 2-1-1. So flip this around too. .5 mole of graham cracker are left, and 1 mole got a half a mole of marshmallow left. Why? Well, you started off with 2 and you lost 1.5. 1 mole of graham crackers left. Well, you started off with 4, but you're only going to have 3. Again, why are you going to have 3? Well, again, you're running through the reaction. You started off with 1.5. So double that is going to be 3. You can essentially you're going to use up twice as many graham crackers as you do chocolate. So if I've got 1.5 moles of chocolate, I'm going to use up 3 moles of graham cracker. Oh, okay. So I'm going to have a mole of graham cracker left over and a half a mole of marshmallow. So I can only make as much s'mores as my least amount of, is my limiting reagent, which in this case is my chocolate. I'm going to have a half a mole of marshmallow left over because I was 1-to-1 with that. And I'm going to have 1 mole of graham cracker left over because I was 2-to-1 with that. Okay, geez. So you've got 2 ways of doing this now. You can either do a rice table, which I'm going to show you how to do, or you can do the math method. And you've already done the math. You calculated it through when we went through ingredient by ingredient. So if you identify your limiting reactant ahead of time, you don't have to do the math for each ingredient. You would have identified it and say, wait a minute, I've got, by comparing moles, the least amount of chocolate. I only need to do all that complicated math for one thing. and then you would have gone through. So I don't have to show that again for this one. We'll do it again for another real reaction. Let's do a rice table and see what that looks like. Okay, so this is what you start off with. And remember, with your rice table, you have to be in moles. Okay, so I have got 4 moles of graham cracker, 2 moles of marshmallow, 1.5 moles of chocolate, and I don't have any s'mores. So when this reaction runs, I'm going to lose all my chocolate. Because it's 1 to 1, I can only lose 1.5 moles of marshmallow. Oh, I'm going to need to double. I'm going to lose 3 of my graham crackers, but that's okay. I'm still going to have it left over, and I'm going to make 1.5 moles of s'mores. Oh, okay. So when I'm done, I'm going to have 1 mole of graham crackers left over. And sometimes, if we're not interested in how much we have left over, you'll see excess written because you've got extra. You're going to have 1/2 mole of marshmallows left over. It's extra. It's in excess. My chocolate is gone. I've got 1.5 mole of s'mores left. Oh, well, we've done this before. How much s'mores do you have in grams? Well, you take your moles and you multiply it by your molecular weight. So 1.5 moles times 32.5 grams per mole. Oh, well, you've done that before, and it turns out it's what you did when we did all the math all the way through. It's 48.75 grams. Just like the complicated math method. It's the same thing. So, I'm going to show you 3 examples in the upcoming videos. One of a 1-to-1 reaction, both with the rice table and the math, where you just identify the limiting reagent, and you set up your rice table, and then you do your math only based off that limiting reagent. We'll do one where it's like a 1-to-2 reaction, where it's a simpler ratio. And then I'm going to show you one where it's a more complicated ratio. And I want you to convince you that when you get to those really complicated ratios, it's probably easier to do the math because your table gets a little bit screwy, unless if you're really good about interpreting about what these coefficients in your balanced chemical equation mean, okay? So we'll get a lot of practice. Don't get intimidated. You can do this. Just stay organized. Be right back.